Hello everyone, welcome to IB Math Solution. Today we are going to solve problems from review set 5A. Consider the number sequence 5, 9, 11, 12, 15, 19. Find U2. So we know this is U2, this is U6 and S4 is the sum of these four terms. So I'll leave it for you to solve on your own. I'll go to the next problem. Identify each sequence as arithmetic, geometric or neither. So let's consider 7, -1, -9, -17. So first we need to check the difference. So if we check the difference, -1 minus 7 is going to be -8. -9 minus -1 is going to be -8. And -17 minus -9 is also going to be -8. Since the difference is constant, therefore we can say it is an arithmetic sequence. 4, -2, 1, -1/2. So 4, -2, 1, -1/2. Here we know if we calculate the difference, this difference is -2 minus 4 is going to be -6. 1 minus -2 is going to be 1 plus 2, that is 3. Since this difference is not equal to the other difference, hence since the difference is not equal or constant, we can say not an arithmetic sequence. Now we need to check for the geometric sequence. So we can say the common ratio R is U2 divided by U1, that is going to be -1/2. U3 divided by U2, that is again going to be -1/2. U4 divided by U3, that is again going to be -1/2. Now since R is constant, hence we can say it is a geometric sequence. Now see, 1, 1, 2, 3, 5, 8. 1, 1, 2, 3, 5, 8. Let's check D first, the common difference. Common difference is 0. Here, common difference is 1. Hence, not an arithmetic sequence. Now we need to check for common ratio. So 1 divided by 1 is going to be 1. 2 divided by 1 is going to be 2. Now we can also say not a geometric sequence. Therefore, we can say it is neither. Let's go to the next problem. Find k if 3k, k minus 2 and k plus 7 are consecutive terms of an arithmetic sequence. So we know the arithmetic sequence has 3 consecutive terms. Let's say this is u1, this is u2 and this is u3. Can we say the common difference is u2 minus u1 and it is also equal to u3 minus u2. Now u2 minus u1 is going to be k minus 2 minus 3k and it equals k plus 7 minus u2, that is k minus 2. So we can say k minus 3k is going to be -2k minus 2 equals k plus 7 minus k plus 2. This k will cancel this k and here we are left with 9. So negative 2k equals 9 plus 2, that is 11, and k equals 11 divided by negative 2, or negative 11 by 2. So this is the answer. Let's go to the next problem. A sequence is defined by un equals 6 times half raised to the power n minus 1. Prove that the sequence is geometric. So to prove, we need to find the value of r, and the value of r is going to be u n plus 1 divided by un. Now un plus 1 is going to be 6 times half raised to the power. We'll replace n with n plus 1, n plus 1, and then this minus 1 divided by 6 times half. Now this is un, therefore this term will come as it is. This 6 will cancel this 6, and this is going to be half raised to the power. Now this positive 1 will cancel this negative 1, and we are left with half raised to the power n and minus this power, which is n minus 1. So this comes out to be half raised to the power n minus n plus 1. Now this n will cancel this n, and we are left with r equals half. Since it is a constant number, we can say the sequence is geometric. Find u1 and r. So u1 is going to be 6, and r we have just calculated is half. Find the 16th term of the sequence to 3 significant figures. So u16 is going to be 6 times half raised to the power 16 minus 1. That is 6 times half raised to the power 15. If we calculate it using the graphing calculator, 6 times 1 divided by 2 raised to the power 15. So this is 1.83 times 10 raised to the power negative 4. Now it is asking us to find the 16th term to 3 significant figures. So if we rewrite it, it can be written as 0.000183, and that's the answer. These are the 3 significant figures. Let's go to the next problem. Determine the general term of a geometric sequence given that its 6th term, that is u6, we can write u6 as u1 times r raised to the power 5 equals 16 divided by 3, and its 10th term, that is u10, we can rewrite it as u1 times r raised to the power 9 equals 256 divided by 3. Now considering this equation 1 and this equation 2, if we divide equation 2 by equation 1, we get u1 times r raised to the power 9 divided by u1 times r raised to the power 5 equals 256 divided by 3 times 3 divided by 16. Now this u1 will cancel this u1, 3 will cancel this 3, 16 will cancel 256 16 times. So here we have r raised to the power 9 minus 5, that is 4, and this equals 16. So r can be written as positive or negative fourth root of 16, that is positive or negative 2. Now substituting the value of r in equation 1, we get u1 times negative 2 raised to the power 5 equals 16 divided by 3, or u1 times positive 2 raised to the power 5 equals 16 divided by 3. So in this case, u1 equals 16 divided by 3 times 1 divided by negative 32. So this will cancel 32 two times, and u1 comes out to be negative 1 by 6. And from here, u1 equals 16 divided by 3 times 1 divided by 32. 16 cancels 32 two times, and u1 comes out to be 1 divided by 6. So in this case, the nth term is u1 times r raised to the power n minus 1, and u1 is negative 1 by 6 times r, that is negative 2 in this case, negative 2 raised to the power n minus 1. And in this case, un is going to be u1, that is 1 by 6 here, times r, that is 2 in this case, 2 raised to the power n minus 1. So this comes out to be 2 raised to the power n minus 1 divided by 6. So either this or this is going to be the equation for the nth term. Let's go to the next problem. Insert 6 numbers between 23 and 9 so that all 8 numbers are in arithmetic sequence. Now here I want to show you a concept that says if we have two terms, that is u1 and u2, in an arithmetic sequence, then we have only one difference in between them. If we have three terms, then we have one difference from u1 to u2, and the second difference is from u2 to u3. So in case of three terms, there are two differences. Similarly, in case of four terms, there will be three differences. So can we say common difference is u2 minus u1, or u3 minus u2. Similarly, if we take directly from u1 to u3, we can say 2 times difference is u3 minus u1, or D, common difference is u3 minus u1 divided by 2, and we can rewrite it as D equals u3 minus u1 divided by 3 minus 1. If we generalize this, we can say common difference can be written as nth term minus mth term divided by n minus m. This is the general formula for calculating the value of common difference D. So this is a formula. Now coming back to the problem, we know u1 is 23. We know u1 is 23, and there are 8 numbers. So u2, u8 equals 9. Now we know we can say the common difference is going to be u8 minus u1 divided by 8 minus 1. So 9 minus 23 divided by 7. So this is going to be negative 14 divided by 7 is equals to, so common difference is negative 2. Now The sequence is 23 and then there are 6 numbers in between, and then the last term, which is 9. If we substitute the value, 23 plus -2 is going to be 21. This is going to be 19, 17, 15, 13, 11 and 9. So these are the numbers. So we have inserted the numbers. Let's go to the next problem. An arithmetic series has 9 terms. The first term is -2 and the last term is 54. Find the sum of the series. So we can say common difference is going to be, now we know there are 9 terms, so un minus u1 divided by n minus 1, which is going to be 54 minus -2 divided by 8. This is 56 by 8, and hence common difference is 7. We know u1 equals -2. So the formula for sum is Sn equals n divided by 2, 2u1 plus n minus 1 times d. So S9 is going to be 9 divided by 2, 2 times u1, that is -4, plus n minus 1, 9 minus 1 is 8 times d, d is 7. Now whatever comes is the answer. Let's go to the next problem. Theodore is squeezing the juice from some lemons. When he has squeezed 6 lemons, he has collected 274.3 milliliters of juice. Find the average amount of juice collected from each lemon. So this number divided by 6 is going to be the average. Hence, write an arithmetic sequence un which approximates the amount of juice collected from squeezing n lemons. So whatever we get as the answer here, we'll multiply it by n, and that is going to be the answer here. Predict the amount of juice collected from squeezing 13 lemons, and here we'll find S13. So this problem is very easy. I'll leave it for you. I'll go to the next one. Find the sum of each of the following infinite geometric series. So I'll solve this one. This one is for you to solve on your own. u1 is 18, u2 is -12, hence r equals u2 divided by u1, -12 divided by 18, that is -2 divided by 3. Now absolute value of r is 2 divided by 3, and it is less than 1. Hence this infinite geometric series is convergent and we can find the sum. So S is going to be u1 divided by 1 minus r. u1 is 18 divided by 1 minus -2 by 3. So it is 18 divided by 5 by 3, which is 18 divided by 5 times 3. So this is 36 divided by 5, or 7 and 1 by 5. That's the answer. Let's go to the next problem. Find the sum of this series. Here u1 is 35, un is 20, u2 is 33 and half. So common difference d is going to be u2 minus u1. u2 is 33 and half minus 35 is going to be -3 by 2. We also know that there is a formula for d that says un minus u1 divided by n minus 1. If we substitute the values, we get d equals -3 by 2. This equals un, that is 20, minus u1 is 35, divided by n minus 1. So negative 3 times n minus 1 equals 2 times 20 minus 35 is going to be negative 15. So negative 3 times n minus 1 equals negative 30. This negative 3 cancels negative 30 10 times. So n minus 1 equals 10 and n equals 11. We know there are 11 terms in this series. So Sn equals n divided by 2 times u1 plus un. So S11 is 11 divided by 2, u1 is 35, un is 20. So this becomes 11 by 2 times 35 plus 20 is 55. So this number is going to be the answer. Let's go to the next problem. Each year, a school manages to use only 90% as much paper as the previous year. In the year 2010, they used 700,000 sheets of paper. Find how much paper the school used in the years 2011 and 12. So let's say 2010, 2011 and 2012. So let's say this is U1, this is U2 and this is U3. So U1, so U2 also equals U1 times R and U3 also equals U1 times R square, where U1 is 700,000. So U1R is going to be 700,000 times 0.9, since the value of R is 0.9. And in 2012, this is going to be 700,000 times 0.9 square. So whatever this value is and this value, they both are going to be the answer for 2011 and 2012. How much paper did the school use in total in the decade from 2008 to 2018? So we know if the number of paper used in 2008 was X, then 2009 had to be X times R, and 2010 had to be X times R square. Now we know the value of 2010, and that is 700,000. In that case, the value of X is going to be 700,000 divided by R square. Now the value of R is 0.9, so 0.9 square. So in 2008, paper used is going to be 700,000 divided by 0.9 square, that is 864,197. Now the value in 2008 has to be U1, 864,197, and R is 0.9. The value in 2018 is going to be U10. We need to find the sum for 10 years. Write a formula for the general term UN. So 86, 83, 80, 77. We know it seems to be an arithmetic sequence. The UN is going to be U1 plus n minus 1 times D. U1 is 86, n minus 1 times D. D is 83 minus 86, that is negative 3. So 86 plus negative 3n minus negative 3. So this becomes 86 plus 3, that is 89 minus 3n. That's the answer. Now here hint says one of these sequences is neither arithmetic nor geometric. Now B has 3 by 4, 1, 7 by 6, 9 by 7, and so on. Here we know that difference u2 minus u1 is 1 minus 3 by 4, that is 1 by 4. u3 minus u2 is 7 by 6 minus 1, that is 1 by 6. These two differences are not equal, hence not an arithmetic sequence. Let's try a geometric sequence. R equals u2 divided by u1, that is 1 divided by 3 by 4, or 4 divided by 3. Similarly, u3 divided by u2 is 7 by 6 divided by 1, or 7 by 6. Again, the ratio is not equal, hence we can say not a geometric sequence. So we need to come up with something that gives us more meaningful relationship between the terms. So can we write this sequence as 3 by 4? 1 can be written as 5 by 5. Now this is 7 by 6, 9 by 7, and so on. Can we say that the numerator is increasing by 2 each time, and the denominator is increasing by 1 each time? Therefore, we'll have separate arithmetic sequence for the numerator and the denominator. So we'll treat the numerator as one arithmetic sequence and the denominator is another arithmetic sequence. So for numerator, we can say nth term is going to be u1, that is 3, plus n minus 1 times t, that is 2. So this becomes 3 plus 2n minus 2, which is equal to 2n plus 1. And for the denominator, the nth term is going to be u1, that is 4, plus n minus 1 times d, that is 1. So this is 4 plus n minus 1 becomes n plus 3. And now we can combine these numerator and denominator together to form the nth term for the complete problem. So this is going to be 2n plus 1 divided by n plus 3. That's the answer. Similarly, for C, we can see that this is times 0.9, this is again times 0.9, this is again times 0.9. Therefore, u1 is 100, r is 0.9, and hence we can find un, and that is going to be u1 times r raised to the power n minus 1. Let's go to the next problem. Expand and hence evaluate. So if we expand this, this is going to be 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 square. And using the graphing calculator, we can calculate it. We go to math and summation. We substitute k equals 1 to 7 k square, and this comes out to be 140. B, if we expand this, this becomes, for k equals 1, this will be 1 plus 3, that is 4, and 1 plus 2 is 3. 4 divided by 3. This is going to be 5 divided by 4, 6 divided by 5, and 7 divided by 6. So again, k equals 1 to 4, k plus 3 divided by k plus 1, k plus 2. So this comes out to be 99 divided by 20, and that's the answer. Let's go to the next problem. The sum of the first n terms of an infinite sequence is this, where n is a set of positive integers. So the value of n is going to be 1, 2, 3, 4, and so on. Find the nth term. Can we say the nth term is going to be sum of n terms minus sum of n minus 1 terms? Now substituting in this formula, we get 3n square plus 5n divided by 2 minus 3 times n minus 1 square plus 5 times n minus 1 divided by 2. Taking a common denominator, we get 3n square plus 5n minus 3 times n square plus 1 minus 2n minus 5 times n minus 1. So this is 3n square plus 5n minus 3n square minus 3 plus 6n minus 5n plus 5 divided by 2. Now this 3n square cancels negative 3n square, and 5n cancels negative 5n. So this becomes 6n, 5 minus 3 is 2, divided by 2. And simplifying it further, we get 3n plus 1. This is the nth term. Prove that the sequence is arithmetic. So in order to prove that the sequence is arithmetic, we need to find the common difference, and common difference is un minus un minus 1. So un is 3n plus 1 minus 3 times n minus 1 plus 1. So un is this, un minus 1 is this. This becomes 3n plus 1 minus 3n minus 3 plus 1. So 3n plus 1 minus 3n minus 2. So this is 3n plus 1 minus 3n plus 2. Now we know 3n cancels negative 3n, and this comes out to be 3. Since the common difference is a constant, hence it is an arithmetic sequence. Let's go to the next problem. 12,500 pounds is invested in an account which pays 4.25% per annum interest. Find the value of the investment after 5 years. If interest is compounded, so I'll solve this one monthly. We know the rate is 4.25% per annum. So R is going to be 4.25 divided by 12% per month. We know time is 5 years. So N is going to be 12 times 5, that is 60 months. Now principal is 12,500. So amount is going to be P times 1 plus R upon 100 raised to the power n. So 12,500 times 1 plus 4.25 divided by 12 times 100 raised to the power 60. So this becomes 12,500 times 1 plus 4.25 divided by 12 times 100 raised to the power 60. So it becomes 15,453.77 pounds. That's the answer. Let's go to the next problem. Jana invested 6,000 euros in an account which pays 5.2% per annum interest compounded quarterly. For 6 years, use technology to find the future value of the investment. So, present value is 6,000, interest per annum is 5.2, compounded quarterly means n equals 4 times 6, that is 24. Now the future value is going to be apps, finance, TVM Solver. So n is 24, interest per annum is 5.2, present value is 6,000, PMT should be 0, future value we are supposed to calculate, and P by Y, C by Y has to be 4 because it is compounded quarterly. So future value is going to be alpha, enter 8,180 euros. That's the answer. The interest earned is going to be 8180 minus 6,000. That is 2180 euros. That's the answer. Let's go to the next problem. 4 years ago, Chelsea invested some money in an account paying 6.5% per annum interest compounded quarterly. There is currently $6,212.27 in the account. How much did Chelsea invest originally? So we are supposed to calculate the present value where we have interest 6.5, n is 4 times 4, that is 12, and future value is 6212.27. So using the graphing calculator, n is 12, I is 6.5, present value we are supposed to calculate, PMT should be 0, future value is 6212.27, and it is compounded quarterly, so P by Y and C by Y both are going to be 4. So calculating the present value, it comes out to be negative 5,119.69 dollars. That's the answer. Let's go to the next problem. For how long must I invest 4,000? So present value is 4,000. I is 8%. N is going to be 4 times the number of years. And future value is 10,000. So one of the values has to be negative. So let's see. So investing 4,000 is the money going away. That Therefore, this is going to be negative 4000. Now, I is 8, present value is negative 4000, PMT is 0, future value is 10,000, and it is compounded monthly, that's why 12. Calculating the value of n, we get 137.9. So n is equal to 138 months. That's the answer. You can convert it into years if you want. Let's go to the next problem. If inflation averages 2.5% per year, calculate the value of 6,000 indexed for inflation over 4 years. 11,200 euros indexed for inflation over 7 years. So I'll solve this one only. They both are exactly same. So present value is 11,200. R is going to be 1.025. So future value, and we know n equals 7. So future value is going to be 11,200 times 1.025 raised to the power 7. $11,200 times 1.025 raised to the power 7. This is 13,313.28 euros. That's the answer. Let's go to the next problem. Georgia invested $20,000 in an account which paid 6.2% per annum interest compounded monthly for 3 years. Inflation averaged 1.8% per year over this time. So present value is 20,000. So let's make this negative. We'll use TVM Solver. Interest is 6.2. N is 12 times 3, that is 36. So future value is going to be N is 36, I is 6.2, P is negative 20,000, and it is compounded monthly, that's why 12. So future value is going to be 24,076.91 dollars. So this is the future value. Find the real value of the investment. So real value, we know real value is going to be future value divided by inflation raised to the power number of years. So 3. Future value is this 24,076.91. Inflation is 1.018. So 1.018 raised to the power 3 is going to be 22,822.20 dollars. So this is the real value of the investment today. Show that 28, 23, 18, 13 is an arithmetic sequence. Now we have done these kind of questions many times, so I'll leave it for you. I'll go to the next one. Consider the arithmetic sequence. Find the 8th term. Find the sum of the first 10 terms. The sum of the first n terms is 915. Find the value of n. I'll leave this one as well for you. I'll go to the next one. A truck is purchased for $135,000. It depreciates at 15% per annum for 5 years. So R is going to be 0.85. Present value is 135,000. N is 5. Find the value of the truck at the end of this period. So future value is going to be present value times R raised to the power n. Present value is 135,000 times 0.85 raised to the power 5. This value is going to be the answer. By how much has it depreciated? Let's say, so PV minus FV is going to be the answer here. Let's go to the next problem. Determine the number of terms in the sequence. So we know U1 is 128, R is U2 divided by U1, that is 64 divided by 128, and hence half. We know Un is U1 times R raised to the power n minus 1, and the value of Un is 1 by 512. This equals U1 128 times half raised to the power n minus 1. So 1 by 512 equals 128 divided by 2 raised to the power n minus 1. But 2 raised to the power n minus 1 is going to be 128 times 512. Now 128 is 2 raised to the power 7 and 512 is 2 raised to the power 9. They combine to make 2 raised to the power 16. Hence n minus 1 equals 16, or n equals 17. Therefore 17 terms. That's the answer. Find the sum of these terms. The sum of first two terms of an infinite geometric series is 90. So u1 plus u2 equals 90. The third term is 24. u3 is 24. And we can also write u3 as u1 times r raised to the power 2. Consider this equation 1, and we can also write u1 as u1 and u2 as u1 times r. And we can write this equation as equation 2. Show that there are two possible series and that both series converge. So we need to solve u1 plus u1 times r equals 90. So this becomes u1 times 1 plus r equals 90. Similarly, u1 r square equals 24. So from here u1 is 24 divided by r square. If we substitute the value of u1 from here in this equation, we get 24 divided by r square times 1 plus r equals 90. So 1 plus r divided by r square equals 90 divided by 24, or 24 plus 24r equals 90r square. Taking 2 common from both sides, we are left with 12 plus 12r equals 45r square. Taking everything on one side, 45r square minus 12r minus 12 equals 0. Now solving this quadratic equation, so this is 45, this is negative 12. If we multiply 45 with negative 12, we get negative 540. Now we need to come up with two numbers such that the sum of those two numbers is negative 12 and product is negative 540. We can say those two numbers are negative 30 and 18. If we add these two numbers, we get negative 12. If we multiply these two numbers, we get negative 540. So the equation can be written as 45r square minus 30r plus 18r minus 12 equals 0. Taking 15r common, we get 3r minus 2. Taking 6 common, we get 3r minus 2. Hence 15r plus 6 times 3r minus 2 equals 0. So we can say r equals negative 6 by 15 or 2 by 3. In both cases, the absolute value of r is 6 by 15, which is less than 1, and 2 by 3, which is also less than 1. So in both cases, the series converge. So we have shown it. And since there are two values of r, there are two possibilities for the series. Let's go to the next problem. After years of decline in his health, Tim has now realized that smoking is unhealthy. Until now, he has regularly smoked 120 cigarettes each week. To help him quit, he is determined to reduce this amount by 5 cigarettes every week from now on. Explain why the number of cigarettes Tim smokes each week will form an arithmetic sequence with U1 115. State that common difference for the sequence. We know this is very simple. U1 is 115 and we know he is cutting his cigarettes by 5 each week, therefore common difference is going to be negative 5. How many weeks will it take before Tim has smoked his last cigarette? So UN must be 0. U1 plus n minus 1 times d equals 0. 115 plus n minus 1 times negative 5 equals 0. So this becomes 115 equals n minus 1 times 5, or n minus 1 equals 115 divided by 5, which equals 23, and n equals 24. So it will take 24 more weeks for Tim to smoke his last cigarette. Find the total number of cigarettes Tim will smoke before he successfully quits. So Sn equals n by 2 times 2u1 plus n minus 1 times d. Now the value of n is 24. 24 times S24 equals 24 divided by 2. 2u1, u1 is 115 plus n minus 1, n is 24, so 23 times d is negative 5. So 12 times 230 minus 115. So 12 times 115. This is going to be 1380. And that's the answer. Let's go to the next problem. Competition offers 3 options for the first prize, each of which pays the winner a monthly sum for 24 months. Option 1, $8,000 per month. Option 2, $1,000 in the first month, then each successive month pays 600 more than the previous month. Option 3, $500 in the first month, then each successive month pays 20% more than the previous month. Calculate the total prize value for option 1. Total prize money is going to be 8,000 times 24. 192,000. For option 2, write down the amount won in each of the first 3 months. So 1000 for the first month, 1600 for the second month, and 2200 for the third month, and so on. Calculate the total amount won over the 24-month period. So we can say U1 is 1000, common difference is 600. So S24 is going to be 24 divided by 2 times 2 times U1, that is 2 times 1000, plus n minus 1, that is 24 minus 1, 23, times D, that is 600. So this becomes 12, this becomes 2000, and 23 times 600 is 13,800. If we add 2000 and multiply by 12, we get 189,600. $189,600. That's the answer. For option 3, write down the amount won in each of the first 3 months. So the amount won will be 500. Now 500 times 1.2 and 500 times 1.2 square. So we can write it as 500 times 1.2, that is 600, times 1.2 again, that is 720. Calculate the total amount won over the 24-month period. So Sn is going to be U1 times r raised to the power n minus 1 divided by r minus 1. So 500 times 1.2 raised to the power 24 minus 1 divided by 1.2 minus 1. So this becomes 500 times 1.2 raised to the power 24 minus 1 divided by 0.2, or rather 2500 times 1.2 raised to the power 24 minus 1. So 2500 times 1.2 raised to the power 24 minus 1 is $196,242. Which option is worth the greatest amount of money overall? So in option 1, it is 192,000. In option 2, it is 189,600. And in option 3, it is 196,242. So option 3 is the best. So we have done this, and this. The amount won in the first month under option 3 is to be altered so that the total price over 24 months is $250,000. Calculate the new initial amount, giving your answer to the nearest cent. So we know S24, that is U1 times R raised to the power n is 24 minus 1 divided by 1.2 minus 1, has to be equal to 250,000. We need to find the value of U1. U1 times 1.2 raised to the power 24 minus 1 divided by 0.2. So this is 250,000. So we can say 1.2 times 1.2 raised to the power 24 minus 1 divided by 1.2 minus 1 is 392.48. So this number u1 is going to be 250,000 divided by this value, the value we have got here, and that is going to be 250,000 divided by the answer. So it is 336.97 dollars. That's the answer. Let's go to the next problem. Consider the infinite geometric sequence. Write the 12th term of the sequence in the form k root 2. So u1 is 160, u2 is 80 root 2, r is going to be u2 divided by u1, that is 80 root 2 divided by 160. So r is going to be 2, this cancels and comes root 2, so r is going to be 1 divided by root 2. Now the 12th term is going to be u12, that is u1 times r raised to the power 12 minus 1. So u1 is 160 times 1 divided by root 2 raised to the power 11. So we can write it as 160 divided by root 2 raised to the power 10 times root 2, because they both will add up to make 11. So this becomes 160 divided by 2 raised to the power 5 times root 2. Now 2 raised to the power 5 is 32. So 160 divided by 32 root 2. If we multiply root 2 in the numerator and denominator both, we get 160 root 2 divided by 32 times 2, that is 64. And this is going to be 10 by 4 root 2. And again we can cancel it, it becomes 5 by 2. So the answer is 5 by 2 root 2. So the value of k, this is in form k root 2. The value of k is 5 by 2. Find in the form a plus b root 2, where a and b both are integers. S10. S10 is going to be u1 times 1 minus r raised to the power 10 divided by 1 minus r. So u1 is 160 times 1 minus 1 by root 2 raised to the power 10 divided by 1 minus 1 by root 2. So this becomes 160 times 1 minus 1 by 2 raised to the power 5 divided by 1 minus 1 by root 2. And this can be written as 160 times 2 raised to the power 5 is 32. 32 minus 1 is 31 divided by 32, and root 2 minus 1 divided by root 2. So root 2 will go over here. 32 cancels 165 times. So this becomes 155 root 2 divided by root 2 minus 1. Now if we rationalize, we get root 2 plus 1 in the numerator and denominator, and this becomes 155 root 2 times root 2 plus 1 divided by a minus b times a plus b is going to be a square minus b square, that is root 2 square minus 1 square. Root 2 square is 2, 1 square is 1. So this becomes 155 times 2, that is 310, plus 155 root 2, and in the denominator we have 1. This is exactly the form the question is asking to write. The value of A is 310 and the value of B is 155. Now we need to find the sum of infinite series. So the sum of infinite series S is going to be U1 divided by 1 minus R. This is going to be 160 divided by 1 minus 1 by root 2. So 160 divided by root 2 minus 1 times root 2 in the numerator. And to rationalize the denominator, we can multiply by root 2 plus 1 in the numerator and denominator both. So we'll get 160 times 2 plus 160 root 2 in the numerator and 2 minus 1 in the denominator. So this is going to be 320 plus 160 root 2 divided by 1, and that's the answer. That's it for this exercise. I'll see you in the next one.